Alright, so when we start talking about properties of logs, the first thing we want to do is keep this big picture in mind, which is logs and exponents are inverses. Inverses is a very fundamental idea in mathematics. It started back in like first grade. You started with your little fact families, adding and subtracting. Then in third and fourth grade, you did multiplying with dividing. Then later in middle school, squaring and taking the square root. Much of math is built around the idea of an operation does something, and then there's an inverse operation that undoes that something. And so logs and exponents are inverses, and they're related to each other. So as we look at the properties of logs, we're also going to be reviewing the properties of exponents. Alright, so our first property says log base b of 1 is equal to 0. This is going to apply for any b that doesn't equal 0. So any base that you have that's not 0, if you take the log of 1 in that base, it's going to be equal to 0. And so you might be thinking, well, why? Why does that work? Well, remember that to convert from a log equation to an exponent equation, the base is the base. So this equation becomes b to the 0 power is equal to 1. And we've already studied the patterns to know that any base not equal to 0 raised to the 0 power is 1. So this log property is just saying the same thing. Alright, next property is that log base b of b is equal to 1. Why does that happen? Well, again, let's rewrite it as an exponent. If we rewrite this in exponential form, b to the first power is equal to b. Well, yes, we know that's true. Any number to the first power equals itself. So this is just that same idea written in logarithmic form. All phones should be put away. You should be focusing on what you're doing. Alright, next one, we have log base b of b to the x power. That is equal to x. Well, how do we make sense of that one? So let's rewrite this guy as an exponential. The base is the base, so b to the x power, this x from over here, equals this argument in the logarithm, b to the x. Well, yes, of course, we know any value is equal to itself. That's obvious, right? Alright, now the last one is actually an exponential equation. B to the power of log base b of x is equal to x. So if you take b and you raise it to the power of log base b of x, you get x. So this is an exponential equation, so let's turn it into its log equivalent. The base is the base. So I would write log base b of x equals this exponent, which is log base b of x. So it's true. Alright, so now let's put these properties into play to evaluate some logarithms. We want to evaluate logs based on properties. We're not going to use our calculators at all. So example 1 is going to say log base 25 of 5. So I want this log expression to come out looking like one of these. So what's the relationship between 25 and 5? Five squared is 25. So I could change my 25 into a 5 squared, but that's not going to match any of these guys. But if 5 squared is 25, doesn't that mean that 5 is the square root of 25? Well, that doesn't seem to help because none of these have square roots in them. But if you take the square root of something, how do you write that in exponential form? Do you remember from algebra that the square root of 25 is equal to 25 to the 1/2 power? Taking the square root of something is the same as raising that thing to the 1/2 power. So I saw some people who were shocked, like, what? I never heard of such a thing. Let's just look at it for a minute here. Square root of 25 equals 25 to the 1/2 power. It's true. So if you didn't know it before, I'm telling you it's true. But why should you believe me? And let me show you. If I have this and I claim that it's true, what happens if I square both sides? Squaring and square rooting undo each other, right? This side is 25. When you raise a power to a power, don't you multiply the exponents? 1/2 times 2 is 1. 25 to the 1 power is 25. So, yeah, it's the same thing. So going back to this problem, I can take this number 5 and I can trade it out. I can substitute it for a 25 to the 1/2 power. So those of you that like to do some color coding in your notes, if we substitute, what I did was I took this number 5 right here, took it out of my expression, replaced it with 25 to the 1/2 power, because 25 to the 1/2 power is the square root of 25, which is 5. Now, why would I want to do that? Because now my base and my number here match. And I have a property that says if the base and the number match to the exponent, the answer is just my exponent. So my answer here is just 1/2. No calculator needed. All right, so I'm going to give you another one. And I want you to use your notes to try and figure out at least the first step. You might not get the whole answer, but I want you to figure out step 1. The problem is ln(e) to the 16th power over 6. Alright, so to talk through what we did. Natural log means log base e. Once you make that substitution, this numerator is now following this property right here. So the numerator is just going to be 16. The denominator is 6. You simplify your fraction. Alright, now we're going to do the 3 other properties. And each one we're going to compare it with what we know about exponents. So we're going to start with the product property. So in exponents, what is x to the 3rd multiplied by x squared? It's x to the fifth. How do you know? You add the exponents, right? 3 plus 2 is 5. Now, if that's never made sense to some of you, you can go back and expand it. X to the third power is x times x times x. And then what we're doing in the middle is we're multiplying. And x squared is x times x. So since we have the same base, however many x's you have here, and then you're going to multiply them by that many x's here, so that's why you're adding the exponents. But the basic connection is multiplication, add the exponents. So when we get to logarithms, if I have the log base b of a product, so if I have multiplication, that's going to equal addition. So it's going to be log base b of the first factor, which is x, plus log base b of the second factor, which is y. So when I have multiplication going on, I'm going to add my logs together. Just like with my exponents, when I multiplied my exponents, I added the exponents to get my answer. So there's the connection. I was pausing so that everybody got that down because I need to switch to a new sheet of paper. Alright. Next we have the quotient property. So again, let's talk about exponents first. If I have x to the fifth power divided by x to the second power, what does that equal? It's x to the third. What did you do with your exponents? Subtract it. 5 take away 2 is 3. For anybody who it's not really clear why this is happening, if I expand x to the fifth, that's x times x times x times x times x. And if I expand x squared, that's x times x. Since everything's being multiplied, I can divide. X divided by x is 1. X divided by x is 1. So the two x's that were here divided out to 1, and then I have 3 remaining. So that's why if I subtract the 2, those are the 2 that divided out, and I have 3 left. So that's why that works for exponents. So what it means in terms of logs is if I have log base b of a quotient, x divided by y, that's going to be equal to log base b of x, my numerator, minus log base b of y. So when I have a quotient, I subtract the logs. Just like here, when I had an exponent and I had a quotient, I subtracted the exponents. Alright, and our last property for today is the power property. And so again, to start with exponents, x squared, and then that quantity cubed. What does that equal? That equals x to the 6th. What did we do with those exponents? We multiplied them. 2 times 3 is 6. That's what you do when you raise a power to a power. If anybody still hasn't grasped why, if I take x squared and I cube it, that means I multiply x squared times itself 3 times. If I'm multiplying like bases, I add the exponents. 2, 4, 6. There we go. So what does this mean in terms of logs? It means if I have log base b of x to the p power, So when I have a power, that power is going to be a multiplier. That's going to be P times log base B of x. So the power does multiplication. Just like the exponents, power to a power does multiplication. Alright, so now I'm going to give you one to try and evaluate. So here's problem 3. Log base 6 of 18 minus log base 6 of 108. Alright, I want you to at least think of what's going to be the first step. Write down what you think the first step is. So, the first step, I heard your groups talking about it, is going to be log base 6 of 18 divided by 108. Agreed? Okay, so now you want to take 18 over 108 and you want to simplify that fraction. So don't turn it into a decimal. Just simplify it. What's the greatest common factor that can go into 18 that can also go into 108? So if I divide by 18 and I divide by 18, I get 1 over 6. Alright. How can I rewrite 1/6 with an exponent? Six to the negative 1 power. Remember, if you have a negative exponent, it's 1 over that amount. So now if I have log base 6 of 6 to the negative 1, what's my answer? Just negative 1. See, I did all that, no calculator needed.